Thank you so much for the invitation, Ulrich and Oliver. Nice organization. I normally speak for 45 minutes, not used to for 15 minutes. Probably I'll take some of your break time and also a little bit of Carlos's start lecture as well. I hope you stand with me. The evolution of architecture practice from hand drawing to computational design and AI. So I'm going to give you a bit overview of where did we all started doing drawings and where we headed to and how computation and AI is embedding into architecture. Luckily, the speakers before me, they did the most part of my lecture as well. Regarding the manufacturing and automation. So I learned so many things as well. So thank you so much for all of them. So my name is Hamid Hassanzadeh. I'm an Iranian architect. I worked as an architect for 10 years and then I founded PA and I go talk to architects about the possible futures that the emergence of new technologies are bringing into our practice. I'd like to start the lecture with a quote from Leonardo da Vinci, which says, nature is the source of all true knowledge. She has her own logic, her own laws. She has no effect without cause, nor invention without necessity. And I like this quote because it emphasizes on the importance of nature in solving its own problems, as we have seen on all these lectures before me, how people are truly searching for solutions inspired from nature. I'm going to get back to that point again at the end of the lecture. So this is the world right now. You see in front of us, full of quite complex geometries, design and built with highly advanced technologies and tools. From smaller scales like products into larger scales of master plans and large buildings with different type of materials. So this lecture is divided into 4 sections: hand drawing, computational design, AI integration, and also I'm going to talk a little bit about PA as well. So the hand drawing era almost started 30,000 years ago when we start drawing on the walls to deliver a message about a threat or a little bit about a possible thing that we can transfer to another humans. Then it goes on until the Egyptian era of 6,000 years ago, where we started developing writings, and it goes on until we have medieval. So if I'm passing too fast, so sorry, because I needed to hide so many slides to fit into the timing, and I'm nervous about that, so sorry for that. So during the medieval time, we started painting the real world images of the images of real world, and you can see the development of one-point perspective on all of these images. And during Renaissance time, these paintings got more and more realistic, and somewhere close to 15th and 16th century, we had the two-point perspective, which is the emergence of drawings officially entering to architecture. And we started drawing buildings before they get built. We visualize them, we imagine them, and you can see all these great works from Palladio, Brunelleschi, and from 15 and 1600s, clearly showcasing the building before it gets built. And this continued on the 16th, 17th century, and it became a undetachable part of architecture, where we transferred the message through drawings until 1940s, 50s, where this is the phase of a new an architectural office that is a lot of architects working or designers working on papers to draw stuff as a tool. So the right side image, it looks like an AI generated image, but it's not as scary as it looks like. But it's an actual image, and it's a picture taken. But this continued until, in parallel, we developed different type of tools that are emerging into architecture. If we want to start with computational design, the analog computing started almost like 700, 800 years ago with architects like Ali Akbar Isfahani working on car bandies, and also different geometrical explorations to deliver these kind of religious mosques in Iran. Or Antoni Gaudi's hanging chain models are great examples of this, how material computing started to shape and come to architecture. The hanging chain models are the flipped version of the structural models that Antoni Gaudi used to design his fascinating buildings. And this is an example of what he was thinking. This is a kangaroo, which is done quite recently, and it's not exactly the same model, but you can see the simple representation that Antoni Gaudi was trying to do with his buildings. Then Frei Otto, another German engineer and architect who experimented so much with soap bubbles into finding forms that are adaptable and can have quite stable structures. A soap film is a structure that to stay stable, it tends to reduce its surface. I'm sorry, the video is not playing, and it has audio as well, but it's okay. And you can see that based on all these explorations, how Frei Otto was able to design incredible buildings, structures that he had worked on in 60s and 70s. And German Pavilion in Montreal, Quebec is a great example of this, and Munich Olympic Center is another example of these material explorations. Luigi Moretti is another Italian architect who invested a lot of his time on designing with multiple parameters. And this is stadium that never got built, but designed with parametric design is the first example of parametric architecture. And it's he's the owner and the person who coined the term parametric architecture as well. Felix Candella's incredible building designs regarding the thin shell concrete, reinforced concrete, thin shell models with reinforced concrete, which are truly masterpieces of the material computing. 2D drafting era almost started with Ivo Sutherland's sketchpad in 1963, where he was working with different screens to design something on the screen, basic geometries with a unique pen. Because of course, high costs of these softwares, it was not quite easy to adapt into architectural practices and workflows. Pierre Bezier, a French engineer who worked on parametric curves or Bezier curves. If you have worked with 3D modeling softwares like Maya, 3ds Max, even Rhino, you've seen definitely the Bezier curves, where he used to mathematical relations and formulas to rationalize any curve on the computer environment. And this is a quote from the Raynaud management that they said to him when he invented this. But after the invention of the computers, we went back and used his codes to model those curves in the computer environment. 3D modeling era almost started with Greg Lynn, not with Greg Lynn, but with Columbia University research like Bernard Tschumi, Greg Lynn, Hani Rashid, and a bunch of other guys who were trying to use codings into generating 3D models, and they were trying to rationalize these spaces that they can do. And this is a good example of what Greg Lynn did back then, and also the forms that he generated with Greg Lynn form practice. Frank Gehry is another architect who almost opened the floodgates of using softwares into architecture with his works like Barcelona Fish, where he spoke to CATIA company, bringing someone from CATIA company to his office to 3D model what he was trying to build, in this case, which is a Barcelona fish. And he had a good interest in the fish structures. But after a couple of attempts that he calls CATIA company, they tell him, oh, we're not in the fish business, we're in the bird business. We build airplanes, we don't build fish. So, but after a couple of attempts, he brings someone from CATIA company to his office, and then the rest is the history, creating projects like Bilbao Museum, which is one of the greatest architectures of previous centuries. And you can see the details of these his sketch and the 3D model he was trying to do. Along with all these tools that were emerging from AutoCAD, from Revit, and other softwares that were being developed, design computation era almost started with the software called Grasshopper, which you guys all know about it, which enables architects and designers to make visual scripting on the screen. Instead of coding on Python codes, they would be able to write visual scripts. And this was much easier for them to understand the codes and work with them. And you can see it's in this example. This is a very short video of how, without drawing any line or any geometry, you are coding your geometry, and you're creating a space or something like that. And with the emergence of Grasshopper, which was basically in 2007 explicit history, it enabled architects to store data, and they can change all those data or play with all those parameters along the way until the end of the design process. And this became an architect's toolkit to generate forms. And these codes can be getting more complicated and complex than this. And again, for Revit, they developed a software called Dynamo, which does the same work for Revit that Grasshopper does for Rhino. And these code can get quite complicated and complex as well. And the final outputs are these architectures that we see on the screens with highly complex elements and structures, which is not quite possible to imagine, let alone build them. But we are just using softwares to imagine them and then build them. And these structures have their own sense of beauty as well, which emerged after since this century, that we got equipped ourselves with more tools in the recent years. Building information modeling emerged when we started using an ecosystem of softwares together to transfer data, to analyze and optimize those data, to create high quality structures that are more optimized into the nature and the environment. And this led us to also work with engineers and other disciplines simultaneously on different type of files. Structural engineers, mechanical engineers, electrical engineers, and we reached to a point that digital twin creation of the same building got much more important than the building itself at some point. It is as important as the building itself. So we can see all the life cycle of the building in one file, and how we can, what we're gonna do about the building's materials after the life cycle ends, or how we can make it more efficient, or different kind of analytics that we can monitor in a physical model, in a virtual model. And this created also an ecosystem of different tools, different technologies that we can connect to each other. I can connect my bike to my house and measure the energy consumption of it. I can connect my car to my house, or different things could be connected to each other for more much better performance. The automation in manufacturing, which all our speakers almost covered it, I'm going to pass it, tools like 3D printing, which allow us to build faster in some points and build much better, and in some cases much stronger, using different robots and different kind of tools like drones in collaboration with each other to create incredible structures and pavilions, in this case with ICT's explorations and these pavilions that they are doing, or cobots, 3D printing models that are incredible example of this, or icon builds, technologies that they're developing recently. They're quite example, even using earth materials to build houses and structures automated and quite fast, and build even on other planets. If we are able to automate these things, why not to think about building on other planets, on Mars or on Moon, that in this case with ICON's collaboration with BIG, you can see the good examples. And CNC milling and building with stripes, what are the good ways of exploring and building with the stripes and spatial understanding of the forms, or using different kind of HoloLenses to build those stripes, are all great examples of these tools emerging with our industry. And even smaller scales like building chairs and having prototypes and customizes of these chairs, each unique and built differently from each other for each person. And even using virtual reality goggles to design in VR and directly send it to manufacturing, like this chair that has been done with Arturo Tedeschi. So where do we go with AI integration? Actually, what is AI? Let's first cover this part. All the advancements in artificial intelligence or computer science is because of the advancements in understanding of the human biology and the developments that we are discovering from human brain. And in this slide that you can see, the neurons are quite similar that what those data scientists or developers are doing with artificial neural networks. Time to time, it's getting us more understanding mistakenly that the AI softwares are like robots that they're gonna kill us or something, which is a wrong representation. And a good example of this, the movie Her, that the character speaks to an AI agent and falls in love with her, and the rest is the movie that you can watch, and quite interesting. Or the book Deep Thought, the book Hitchhiker's Guide to the Galaxy, where Deep Thought is the name of the computer algorithm, which is an AI system, and it does everything for the users which they ask. And these AI systems are not going to be robots sitting next to you working on your tasks, but an algorithm that can do everything for you inside your PC. And the basic versions of these, you have used them in your social media while you're doing search or something, that it suggests you based on your experience. How does it generate images? We're not going to get into much of it. I'm going to skip these. But the first images of an AI system that created was this pose invariance image, where they have been trying to generate a dog image, but it's not a dog image that AI generated. It seems like I can see a dog in here, a lighthouse, a snake in here, which is trying to hallucinate of the text that was written on the system to showcase a dog. It developed quite some time until we saw these kind of art images that are generated via AI, and it won a competition, an art award actually in 2018. And from those points, we have been seeing some of the similar hallucinations that people were trying to explore opportunities by feeding their images into system and getting the same type of images. In this case, Daniel Bolotjan, what they did with Deep Himmelblau, the company called Coop Himmelblau, Wolf Prex's company, they fed a lot of their images into system to get the similar designs as Deep Himmelblau, as Coop Himmelblau, which was quite successful. And another good example of this is the Zaha Hadid collaboration with Refik Anadol, which they had an early access to DALL-E back then in 2021. And they fed a lot of Zaha Hadid architects' images to receive or to have some images similar to Zaha Hadid architects' designs. And in this case, you can see Zaha Hadid is not there, but they can feed the images and they can get similar designs. So what are some of the tools that are doing these kind of things? Definitely you've worked with Launchbox ML, which is a great tool for panelization or similar kind of functions that it does. Hypar is a good example of a text-to-image, text to 3D model flooring, let's say, where you can type stuff and it will just generate for you different models that you can have. These are the basic levels, I can agree, but these models are getting quite advanced in the last couple of years. And what Jasper Walgren is doing with Finch 3D, with all these adaptive plans are incredible. And they have launched this last year, and it's quite working and quite adaptive, and it's amazing for architects. You can see on these examples, for example, you can just feed the system with a unique image and get a similar image if you type like a similar architecture close to that image. If you type, for example, Frank Gehry or Zaha or anybody like that. Generating floor plans like in the architectures platform is quite interesting, which is again quite simple, but they're quite getting advanced. Or make it as another platform that does work with AI systems to generate floor plans. And imagine these getting into 3D models. Get Floor Plan is another platform that generates images through, generates plans through your sketches. And then there's Midjourney, which you have all worked on. The Midjourney version 3 was quite favored by all architects. Now with Midjourney 6.2, which is quite advanced, and creating high quality renders, which are quite realistic. Or DALL-E 3, Stable Diffusion, ComfUI, which is being used a lot by architects, and Carlos is going to arrive and give a lecture about it. Quite crazy works that he's generating. It's quite admirable. Kyber for video generation, which is the same hallucinations that I showcased with Refik Anadol's or Daniel Bolotjan's works that could be used for exploration of different type of models actually in architecture. Runway is a good example of it as well. Then imagine that you can have 3D models where you just type a prompt and you get a 3D model of it. OpenAI working on a point E, where you can have a point cloud and turn it into three-dimensional meshes where at the end of the day will be a 3D model for you. Or Genie AI working with another AI system that can generate 3D models, creating textures with Ponzo AI. So what is the future of AI in architecture with all these? There's a saying in automotive industry where they say we won't be allowed to drive cars anymore, and we won't even notice or even care. Toby Walsh. So these self-driving cars are growing. Yes, at some point we will, the insurance companies will charge other cars if it's not self-driving, and we will transition to a new type of automotive industry, which is all self-driving. And we won't even care about it, probably. Neil Leach has the same analogy in architecture. We won't be allowed to design buildings anymore, and we won't even notice or even care because the cost of designing with an architect is quite high. If you use AI, probably it's going to be reduced. So I'm not sure if that's true, but what will be the role of an architect and designer with the emergence of all these AI tools? Does this mean game over? Did we create AIs to do our art and literature so we can do the laundry? Are we in the right direction? We created them probably to do our dishes so we can do art and explore literature, writings. Will we be able to win wars or competitions and battles without using any advanced tools? I don't know. But even if it develop all these tools, I think humans love to compete with each other and cheer each other and congratulate each other who we have the objects that are moving faster than humans, but still we are competing with each other and congratulating that. What are some of the ethical considerations of these? I'm going to pass that section. Sorry, I have to close the lecture. So what are some of the challenges that we can overcome? The circular updates can just solve all these things, access and equity to all these advanced tools, preparing for unseen consequences, incorporating trainings and ethics, and talking about the communicating with other interdisciplinary disciplines would solve all these things actually. Talking about ethics is very important in the use of AI. I think it should be taught in architecture schools as well. Studying art and literature is quite important as the tools are becoming easier, let's say. It will be very important for us to explore the beauty and to deliver a beautiful structure. Again, even we have the advanced tools, as an architect, we have to deliver beautiful buildings. And if, even with those advancements, if you're not delivering beauty in your designs, it doesn't worth to work on it, actually. These are undermined values that architects sometimes skip it, but you have to give a good experience, even if you are designing with advanced technologies. You have to take care of scale, function, balance, unity, variety, harmony, materials, and all sorts of design principle, even if you're designing with AI. So in the last 5, 7, 6 years, we've been working on parametric architecture. We started from Instagram, from 0 followers, and then we reached to 1.4 million followers. And we are world's most renowned avant-garde architectural platform about parametric design, computational tools, and AI. Our main focus is the emergence of new technologies in AEC industry and creative industries. Today, our platform reaches to over 20 million people every month on the internet. We are talking to so many architects, asking about their ideas, how they are using these tools in their practices and their daily workflows, and sharing it on the internet. We are teaching all these tools online with huge numbers of architects interested on all these tools. And we're teaching so many great topics on parametric design, 3D printing, with at least, for example, some of these studios get 1,000 attendees online live. We do live printing online, and the students get interested. So in countries like Germany, it's quite available, but other countries, it's not quite available, and it's quite new topic. So me as a personal, as a person who is interested in these stuff, I want to share all these knowledges and democratize all these knowledges and advancements with other people as well. And these are some of the works that students are have generated through the last couple of workshops that we did online with great instructors that we're inviting from all these schools and bringing back to democratizing their knowledge as well. So thank you.